Dart skill presents ratio. A ratio compares two quantities of similar type. For example, we could say the ratio of girls to boys in a class is 1 to 3, also written as 1 TO2 3, and also written as a fraction 1 over 3. And it doesn't mean that the class has got only one girl and 3 boys, 4 in all. It only means that in every group of 4 kids, there's only one girl and 3 boys. You add another group, so that adds one more girl and 3 more boys to the class. So the ratio doesn't give you the actual numbers. It gives you an indication so that you could compare, okay, this class is heavy on boys as compared to girls. Often in educational institutions, we talk about the student to teacher ratio. And we have something like, let's say, 10 to 1 or something. It doesn't mean that the whole institute has got 10 students and only one teacher. It means that for every group of 10 students, on an average, there's one teacher. So if there are 20 students in the institute, there would be 2 teachers. If there are 100 students, there would be 10 teachers and so on. And like I said, it can also be written as 10 to 1 or 10 over 1. They all mean the same thing. And because ratios can be written as fractions and fractions can be reduced to their simplest forms, ratios can also be reduced to their simplest forms. All you need to do is just rewrite the ratio as a fraction and keep reducing it. There are a couple of more things you want to know about. A, in ratio the order matters. Therefore, if we say that the ratio of boys to girls is 3 to 1, it means that in a group of 4 kids, there are 3 boys and 1 girl. The order in which we write this does matter. And then, automatically it implies that the ratio of girls to boys is going to be equal to 1 to 3. If you write this as a fraction, this is 3 over 1. And if you write this as a fraction, it's 1/3. And 3 over 1 is not the same as 1/3. So the order does matter. And B, in a ratio, the first number is called the antecedent. Let me write that down. Antecedent. And the second number is called the consequent. So this is the consequent. Time for us to look into a couple of examples. A class has 24 students, out of which 9 are girls. Find the ratio of the number of boys to the number of girls in the class. Keep the order in mind, it matters in ratio. So we need boys to girls and not the other way around. The number of girls is given as 9. And then the number of boys is nothing but the total number of students minus the number of girls. So that is 24 minus 9, which is 15. So the ratio of boys to girls is 15 to 9. If you want to simplify this, you can rewrite that as 15 over 9 and then divide 15 with 3, 9 with 3. You get 5 on the top and 3 on the bottom. So you could say this is same as 5 to 3. Let's look at another one. A bag contains red, white and black balls. There are 6 red balls and 4 white balls in the bag. If the total number of balls in the bag is 14, find the ratio of the number of black balls to the number of white balls in the bag. So we need black to white. That is equal to, if you look here, there are 4 white balls. So we could write a 4 on the white side. And how about the number of black balls? It's given that there are 14 in all, and there are 6 red and 4 white balls. So if you add these two numbers up, that 6 plus 4 is 10, and subtract that from 14, that gives you the number of black balls. So the number of black balls is 14 minus 10, which is also 4. And obviously, if you want to simplify this, a ratio of 4 to 4 means it's 4 over 4 as a fraction, and 4 over 4 is nothing but 1 over 1. That can be written down as a ratio as 1 to 1. And this actually makes sense because a ratio of 4 to 4, for every 4 black balls, there are 4 white balls, is the same in meaning as for every 1 black ball, there is 1 white ball. So the ratio of 4 to 4 is the same as the ratio 1 to 1.